Hello everyone, welcome back to my YouTube channel. My name is Srishti. I'm in my third semester studying in Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering. Today, I bring forth a video on the subject mathematics on the topic ANOVA and its practical and mathematical example in maths. Let's go through the content of this video. Introduction to ANOVA, components of ANOVA, assumption of ANOVA, one-way ANOVA example, mathematical formulation of ANOVA, calculation of degrees of freedom, F statistics in ANOVA, practical application of ANOVA, two-way ANOVA example, limitation of ANOVA, and conclusion. Now let's learn the introduction of ANOVA. ANOVA stands for Analysis of Variance and it's a statistical method used to compare the means of three or more samples. It helps determine if there are statistically significant differences between the means of the groups being compared. ANOVA is commonly used in research experiments and quality control to make inferences about population means. The components of ANOVA. ANOVA is based on the partition of total variation observed in the data into different sources of variation. These sources include within group variation and between group variation. By comparing the ratio of these variations, ANOVA determines whether the differences in means are significant. Let's learn about the assumption of ANOVA. ANOVA assumes that the data is normally distributed within each group. It also assumes that the variances within each group are equal. Violating these assumptions can lead to inaccurate results and conclusion. Here are some major assumptions of analysis of variance shown on this image. The assumptions include independence, normally distributed, homogeneity of variances. Our purpose is used to examine these assumptions, provide various tests of these assumptions, that is theory and sample essays code, consequences when these assumptions are not met, and the remedial measures. Now let's learn about one-way ANOVA example. Imagine a study comparing the effectiveness of three different teaching methods on student performance. The null hypothesis should be that there is no significant difference in mean scores between the three teaching methods. ANOVA would be used to test this hypothesis by analyzing the variations in scores across the group. The mathematical formulation of ANOVA. ANOVA is of two types, that is one-way and two-way. So let's learn the one-way mathematical formulation. The total variation in the data is composed into the sum of squares total, that is SST. Here, this is SST. And the variation within groups is represented by the sum squares within SSW. That is, SSW is this. The variation between groups is represented by the sum of squares within SSB, which we have to find. Now let's learn the calculation of degrees of freedom. The degrees of freedom for ANOVA are calculated as df total n minus 1, df between is equals to k minus 1, and df within is equals to n minus k. Here, n represents the total number of observations and k represents the number of groups. These degrees of freedom are used to determine the critical values for the F statistic. This is a one-way example or the mathematical formulated table of ANOVA for one way. Here, source of variation within treatments or between sources, sum of squares SSW, which is a summation of I x minus xj whole square. The degrees of freedom is k minus 1. Again, we have learned that k represents the number of groups. Mean square, that is MSW is equals to SSW divided by k DFW, that is k minus 1. Between errors or between treatments, SSB is equals to summation of k j x j minus x whole square. DFB is equals to n minus k. Here n stands for the number of total number of observations and k stands for the number of groups present. MSB is equals to SSB divided by DFB. DFB is n minus k. Here total is equals to summation of n, j is equals to 1 x j minus x whole square. DFT is equals to N minus 1. And this F ratio is equals to MSB divided by MSW. Here is the tabulated formation of one-way ANOVA or analysis of variance. F statistics in ANOVA. F statistics in ANOVA is similar to the F ratio or the F which is present in statistical table or the mathematically formulated table of ANOVA. Here, F statistic is calculated as the ratio of the mean square between groups to the mean square within group. It follows an F distribution and is used to test the null hypothesis of equal means. A large F value indicates a significant difference between group means. Now let's learn the practical applications of ANOVA. ANOVA can be used in various real-world scenarios such as comparing the effectiveness of different medical treatments. It can also be used in marketing research to analyze the impact of different advertising strategies on sales, and ANOVA helps in making informed decisions based on these statistical evidence. This is the two-way ANOVA formulated table or mathematical table. A two-way ANOVA consists of columns and rows. Here, in sources of variation, you can see columns and rows included. Therefore, the sum of squares of columns, that is SSC, is equals to summation of Tj whole square divided by NF minus T square by N. Here, T square by N can also be written as CF. The degrees of freedom between columns can be written as C minus 1, where C represents columns. The mean sum of square between columns, that is MSC, is equals to SS between columns, that is SSC, divided by C minus 1. And F ratio is similarly different between the one-way and the two-way because F ratio here is 2, whereas in one-way there's only one F ratio. The F ratio between columns is equals to MSC divided by MSR. Now between rows, that is the SSR is equals to summation of Ti square by Nt minus T square by N, and degrees of freedom R minus 1, and mean sum of square of rows is equals to SSR divided by R minus 1. And the F ratio of between rows is equals to MS between rows divided by MS residual. Here let's see the residual error, that is total SS. The difference between SSC and SSC is here. And minus degrees of freedom is C minus 1 and R minus 1. And mean sum of square is SS residual divided by C minus 1 and R minus 1. As you can see here, there is no F ratio present. Next, the total is summation of square is summation of square xij square minus cf or t square by n. Here, c into r minus 1 is the degree of freedom. Now let's learn about two-way ANOVA example. In a two-way ANOVA, we analyze the effects of two categorical factors on the response variable. For example, studying the influence of both gender and age and exam scores. Two-way ANOVA allow us to determine the main effects and interactions between the effects of the factors. Let's now learn about the limitations of ANOVA. ANOVA assumes independence of observation within and between groups. It may not be suitable for small size samples or non-normally distributed data. Outliers and influential data points can also affect the results of ANOVA. One-way ANOVA assumption. That is, the ANOVA assumptions of one way include independent sample, normality within each group, and equal variances. Within groups, variances are the same for each of the group. Becomes less important if the sample size is similar among your groups. Conclusion. ANOVA is a powerful statistical tool for comparing means and identifying significant differences between groups. Understanding the component assumptions and calculations of ANOVA is crucial for accurate interpretation of results. By applying ANOVA in various contexts, researchers can make data-driven decisions and draw meaningful conclusions. Thank you. Thank you for your attention and interest in learning about ANOVA and its practical applications in mathematics. If you have any questions or would you like to explore ANOVA further, feel free to reach out. Stay curious and keep exploring the fascinating world of statistics. I hope you like this video. Please do like, share, and subscribe. Thank you so much.